Welcome to 2.7 Solving Inequalities. Now, the first page that we're going to be going over today essentially is just getting some notation down, some different things with regards to notation, and getting you squared away on that, and talking about the rules that we work with inequalities. And the second page we'll be actually doing some inequality problems. So, just a reminder up here, a solution is any number or set of numbers. If we have a set of numbers, it's called a solution set that can be substituted into an equation essentially to make an equation true and an inequality true. So that's what we have. Now, there's a couple different things if you notice over here. There's an inequality inside these set brackets, and this is called set builder notation over here, and it's denoted with these set brackets on either side. Now, this is a graphic representation of the set that it's talking about. And then over here is something that's called interval notation, which we use as well. So if we look at this, this is called a compound inequality. This says all of the x's need to be bigger than a, greater than, not greater than or equal to, and less than b. So when we have less than or greater than, we end up having these open holes there, meaning we're not including the endpoint. As opposed to if you notice here, it says x is less than or equal to b. Well, when we have equal to b, we can include b in our solution set, and that's why we have that closed-in hole. Okay? Or this right here, this says x can be anything between a and b, that is bigger than or greater than or equal to a, or less than or equal to b. Because we have this less than or equal to, we're including a in our solution set, and it appears as a closed hole there. This one here, if a is less than or equal to x, which is less than or equal to b, we're saying that x needs to be between a and b, and we can include a and b, so we'll notice that we have those closed-in holes there. So all these things right here are called bounded intervals. There's an upper and lower bound on these. The ones that we're going to be dealing with mostly in this class are these unbounded. X is greater than a. So if we have x is greater than a, we're not including a, so we have an open circle. X being greater than that, we want all the numbers that are bigger than a right there, and that's a graphic representation of our solution set. X is less than b, well, start at b, but because we have less than b, not less than or equal to, we're not including b, so we have an open circle, and we're shading this way on the number line. And then same thing here, x is greater than or equal to a. The only difference between this and this one up here is the equal to. So now we're including a, so we have a closed circle, and we're shading to the right as well. And then same thing down here. Now notice, if you look at this interval notation over here, if we start at a and don't include a, and we keep going up, we're going all the way positive infinity. That is, we keep going on and on and on. And that's what this represents right here. This says the solution is the set that starts at a. The open parenthesis means not including a. So we always start with the lower bound. It starts at a, just like we do on the graph. We read from left to right, and goes to infinity. So we have the infinity here, which is like the sideways 8. That's an infinity sign. X is less than b. Well, we start from left to right again, but we're going all the way from negative infinity, which is way out to the left. So we start at negative infinity, going up all the way to b. We're not including b because we have less than, so we have that parenthesis. Now, here we have x is greater than or equal to a. Because we have greater than or equal to, we have a closed circle. Whenever we have a closed circle, this comes with square and bracket. So square and bracket means we're including a. So if we think about what's the difference between this interval right here and this interval right here, graphically they look the same, except we have an open circle, meaning we're not including a, so we have the parenthesis. Here, we are including a, so we have the closed circle, and we have the square and bracket. So those are the things that we want to look at here, and we'll continue talking about these things as we go through the actual problems that we're doing. Now, this last one that I do want to talk about just briefly is this. This is the interval that denotes all real numbers. This R right there is all real numbers, and it means you can go anything from negative infinity to positive infinity. It's like the whole number line is closed, is shaded. So that goes from negative infinity to positive infinity, and that's what we have. Now we get to the properties here. Now, the addition property of inequality is this. If a is less than b, if we add the same thing to both sides, we don't switch direction of the sign. Notice, we still have the a on the left, the b on the right, and the alligator is eating the b, and the alligator is eating the b here. So we can add the same thing to both sides of an equation, and we're good. So, I mean, clearly, if 2 is less than 3, if we add 3 to both sides, 5 and 6, when we're comparing those, 5 is still less than 6, so we're adding the same thing. That's good. Now multiplication is a little bit different. We know that 2 is less than 3. If we multiply by a positive, and whatever we do to one side, we do to both sides, just like we did with equations. If we multiply both sides by 2, we have 4 and 6. Well, 4 is still less than 6, so if c is greater than 0, that is, we're multiplying by a positive number, then don't flip the sign. But we all know that 2 is less than 3. If we multiply by a negative number, like let's go with negative 3, whatever we do to one side, we're doing to the other side, this is negative 6, this is negative 9. Well, negative 6 is a bigger number than negative 9, so notice we've had to flip the sign. So when we multiply by a positive, don't flip the sign. When we multiply by a negative, flip the sign. And those are kind of some of the basic rules that we have with inequalities. So I'll see you in the next video for the actual problem solving.